Morning to all. I am Dr. P. Naveen, Assistant Professor, Department of Chemistry, Dr. N.G.P. Arts and Science College, Coimbatore. Today we are going to discuss about the topic is coordination chemistry. So it is a branch of inorganic chemistry. So in chemistry there will be three different type of branches are there. That is organic chemistry, inorganic chemistry, and physical chemistry. So this coordination chemistry comes under inorganic chemistry. The coordination chemistry. The coordination complex consists of a coordination chemistry, coordination compound or coordination complex. Consists of a central metal atom or ion, which is usually a metallic, is called as a coordination center, and it will be surrounding array of bound of molecules or ions that are in turn known as ligands or complexing agent. So generally a coordination compound or coordination complex consists of central metal atom and it will be surrounded by ligands, that is called ions. Okay, so this is the example for one simple coordination complex, that is CO NH3 5 Cl Cl2. So herein that CO is a central metal atom, that NH3. Okay, so NH3 and Cl2 are ligands. Okay, so it will be surrounded by central metal atom, that is called as a coordination compound. So this is the general definition for coordination compound. Then in coordination compound, so we have to, so generally we have seen, okay, coordination compound, so we have to name in the coordination compound. Okay, so first there will be some nomenclature and rules we have to naming the coordination compound. First rule is the cation is named before the anion as in other ionic compounds. So cation we have to name as a first, then we have to go for an anion name. So okay, then within a complex ion, the ligands are named first in alphabetical order and the metal ion is named last. Okay, so ligands are we have to name as a first, then in alphabetical order, and metal ion will be last. Okay, then the names of anionic ligands end with the letter O. Okay, whereas neutral ligands are usually called as named as molecules. The expansions are, there will be two to three expansions are that, it is water we have to name as aqua, and CO as carbonyl, and NH3 as amine. So NH3 we have named as AMINE. Herein we have to name as AMMINE. Then when two or more same ligands are present, so herein just there will be a two type of ligands which will be present in this coordination compound. We have to, so there will be a two or more ligands. We have to use the which as di, tri, and tetra, penta, and hexa. So 2 means di, 3 means tri, 4 means tetra, 5 means penta, and 6 means hexa. You have to specify the number. So prefix are not included determined in the alphabetical order. So when the next rule, when the name of the ligand contains a green prefix, a different set of prefixes used as a ligand. So there will be two ligands which will be present in the coordination compound. We have to name as bis, tris, and tetrakis. So 2 will be in bis, 3 will be in tris, and 4 will be in tetrakis. Then we have to come for a oxidation number. The oxidation number of metal is indicated in Roman numericals immediately following by the name of the metal. So we have to indicate the oxidation number of the metal. We have to indicate it in Roman letter followed by the metal. Then if the complex is an anion, its name ends with 8, and the oxidation state of metals follows with the suffix as 8. Okay, so these are the some rules for organic for coordination compound. So then we are telling us in coordination compound which will be surrounded by ligands. What is the meaning of ligands? Okay, so the atoms or groups which are attached directly to the central atoms are called ligands. So any of the atoms or groups which will be directly attached to the one of the any of the metal center, we have to name as ligands. So ligands are generally a Lewis base which donates the electron pair, forms the coordination bond with the metal atom. So ligands are generally, it will be a Lewis base because it donates the electron to the metal center to form a bond with the metal atom. That is called ligands. For example, water, CO, NO2. So these are the examples. So the ligand may be a neutral, positive, or negative. So there will be a different type of ligands, that is a positive ligand, a neutral ligand, and as well as negative ligand. So it depends upon the ligands, neutral or positive or negatives, then the oxidation state of the metal will be identified. Okay. Then there will be a classification of ligands are there. That is monodentate ligand, bidentate ligand, tetradentate ligand, hexadentate ligand, polydentate ligand. So these are the some classification of ligands. First, mono or unidentate ligands. Why we are telling us mono or unit? So it is an only one ligand. So one donor atom or one point of attachment can coordinate it with the metal ion at only one side of the complex. For example, we are taking a coordination complex or coordination compound. So one of the atom, one donor atom, for example, herein, so we have mentioned as H2O. So that oxygen molecule which will be directly attached to the metal center. So here in one metal atom, that is donor atom, the oxygen is generally, we know very well about oxygen, sulfur, nitrogen, it having a lone pair of electrons, it will be directly attached to the metal center. So the herein the oxygen will having a one oxygen having a donor atom which will be directly attached to the metal atom. So it will be an example for mono or unidentate ligand. So it is a monodentate ligand. For example, you just see the example chlorine, amine, and water are the examples of monodentate ligands. Then poly or multi ligand. So two or more atoms, more donor atoms which will be present in the coordination complex, we will tell as a poly or multidentate ligand. So two or more donor atoms points for attachment. So polydentate ligands are further classified as bi, tri, and hexadentate. So it will be depends upon the coordination. So for example, here in ligand there will be a nitrogen, oxygen. So sulfur there will be a three type of coordination. So there will be a tridentate type of ligand. So we are telling us. So generally we are comparing with the monodentate or bidentate or polydentate. So monodentate means one donor atom which will be present will be directly attached to the metal center, whereas polydentate or multidentate ligand means two or more donor atom. So this is the general differentiation between the monodentate and polydentate ligand. So this way we are telling us that ligands which will be coordinated to the metal center. Then okay, so we are telling as a oxidation state or coordination number. Okay, so why we are telling as oxidation state or coordination number? So which is the ligands which will be attached to the metal center, we will tell as a will be an oxidation state. For example, two negative ligands which will be coordinated to metal center, the oxidation state will be a 2. So depends upon the type of ligands, positive ligands, negative ligands, as well as neutral ligands, depends upon the ligands which we will be telling as oxidation number. Then we have to tell as coordination number. So why we are telling as coordination number? So how many coordination to the metal center? Okay, so for example, so for herein there will be, and so you know very well about, there will be a different type of geometries are there. There will be a linear, trigonal, planar, square planar, tetrahedral, trigonal, bipyramidal, square pyramidal, and octahedral. So depends upon the coordination of that ligands. Okay, so for example, two ligands. For example, cyanide we will take in as a common for ligand. So two cyanide ions which will be coordinated to the metal center, it will be, are telling us it will be linear, it will be at 180 degree. Whereas three cyanide ions which will be coordinated to the metal center, we are telling us trigonal, planar. Then we are going for four coordination system, that is four cyanide ions which will be coordinated to the metal center. We are telling as tetrahedral or square planar. So there will be a two possible geometries for four coordination system. Then we go for five coordination system. There will be a cyanide ions which will be bounded with five cyanide ions with the metal center. We are telling us two possible geometries, that is trigonal, bipyramidal, and square pyramidal. Then we are telling us octahedral geometry. Herein we are telling us six cyanide ions which will be coordinated to the metal center. So we are telling as a octahedral. So it will be depends upon the number of ligands. Okay, so we have to tell us differentiate between the oxidation state as well as coordination number. So oxidation state means number of positive or negative ligands which will be coordinated to the metal center, we are telling as oxidation state. Whereas we are going for coordination number, we have to how many number of ligands which will be coordinated to the metal center, we have to assume that. Okay, so herein we are generally taken as a cyanide as an example for. Okay, so herein we are telling us, so linear, trigonal, planar, tetrahedral, square planar, trigonal, bipyramidal, square pyramidal, and octahedral. So there will be an angle deviation. So linear means we know very well about it's 180 degree. Then we have to go for a trigonal, planar means there will be a deviation in the angle, that is 180 to 120 degree. Then we have to go for tetrahedral and square planar. There will be angle deviation in the 122, 102, 106, that the angles will be deviating. So depends upon the geometry, the angle will be deviating, depends upon the coordination of number of ligands which will be coordinated to the metal center. So these are the some outlines about the coordination number, so coordination compound, and what are the types of ligands which will, and the oxidation state, and the coordination number. So these are the some important responsible for to form as a coordination chemistry. So generally we have to summarize means coordination chemistry is here. It will be surrounded by having a metal ions which will be surrounded by ligands. Okay, ions are ligands. What is that ligand? So one of the ions are molecules which will contain, that is called as a ligands. There will be a number of types of ligands: positive, negative, and neutral ligands. So these are the some outlines about the coordination chemistry. Thank you.